Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. A right circular cylinder has a fixed volume of 25 cubic inches. We want a formula that gives the radius r in terms of the height h, and we also need to decide what values of h make sense, its domain. The volume of a right circular cylinder equals the area of the base, pi times r squared, times the height h. This formula ties radius and height together. Changing one forces the other to adjust, if volume stays fixed. Since the volume is fixed at 25 cubic inches, we substitute V equals 25 into the cylinder volume formula. Now we treat h like the input and isolate r. Divide both sides by pi h to isolate r squared. This step already hints at a restriction. We can't divide by 0, so h can't be 0. Next, take the square root of both sides to solve for r. Since a radius can't be negative, we keep only the non-negative square root. We can rewrite the square root form as 5 over the square root of pi h. Both expressions are equivalent. This makes intuitive sense. To keep volume fixed, a taller cylinder must have a smaller radius. For the square root to be real, and for division to be valid, the expression must be positive, and we cannot divide by 0. Because pi is positive, the sign depends on h, so h must be positive. The height must be greater than 0, so the domain is all positive real numbers. On a graph, radius decreases as height increases. Also notice the function isn't defined at h equals 0, matching our domain restriction. Only positive heights make physical and algebraic sense here. We start from the cylinder volume formula and plug in the fixed volume. Solving for radius gives a clear function of height. The domain is all positive heights, because we can't divide by 0, and we need a real square root. Keep going. Watch the next video to see how these relationships come alive in new problems and surprising variations.